So in the first quadrant, theta is between 0 and pi half, or between 0 and 90 degrees, right?
Mm-hmm.
But you can go on. So in general, this is the definition of sine theta and cosine theta. So imagine that you have the theta is something like this. So the definition is exactly remains the same. For this new theta, so let me just call it, I don't know, alpha, this new angle. Again, we have x and y. So x and y are just x component and y component of this point on the plane. So we have this point, it has an x component and y component, right?
Mm-hmm.
So I just call it x prime and y prime. So for alpha, we do the same thing. So sine of alpha is basically equal to what? Is equal to y prime, right?
Mm-hmm.
And cosine of alpha is equal to x prime. So in the second quadrant, x prime, because the x component in the second quadrant is negative. So in the second quadrant, sine is positive or negative?
Sine is positive.
Sine is positive because y is positive.
Mm-hmm.
But cosine is negative.
Mm.
Okay. How about, I want you to think, how about the third quadrant? So sine is positive or negative?
Sine and cosine are negative.
Both of them are negative because x and if you go to the third quadrant, because x and y are negative in the third quadrant, sine and cosine are both negative. How about in the fourth quadrant? X is positive.
Yes.
But y is negative.
Negative.
Right?
Mm-hmm.
So that means cosine is positive, but sine is negative.
Negative.
So this is the first thing I want you to remember. And you don't have to memorize. You don't have to memorize. You just have to look at this unit circle.
Mm-hmm.
Okay? So, and remember, so maybe I just create a table. So here is a quadrant. Here is sine, and here is cosine. Sine theta, cos theta. So the first quadrant, so in the first quadrant, you can say that theta is between 0 and pi half. Second quadrant, so theta is between pi half and pi. And third quadrant, what is theta? What is the range of theta?
From pi to 3 pi over 2.
From 3 over 2. And in the fourth quadrant,
3 pi over 2 to, I mean, it's 2 times pi.
yes. So it's and 2 pi. So sine the first quadrant and second quadrant psi is positive. In the third and fourth, psi is negative. Cosine positive, negative, negative, positive. But you don't, again, I want to emphasize, you don't have to memorize because you just need to understand the unit circle. And the definition, just look at the definition of sine and cosine, because you know when x and y are either positive or negative. Okay? So some observation from this, looking at this unit circle. So first of all, you can see from here that cosine of, and okay, something I should tell you is that when you have negative angle, so in the unit circle, angle is measured counterclockwise. So we go this way and we measure the angle in this way. So that is counterclockwise. If you go clockwise, then it becomes negative. So positive. If you go this way, the angles becomes negative. That's a convention, okay? So for instance, one thing we can observe here is that the angle minus pi half is equal to 3 pi half. So this angle, in terms of the angles on the unit circle, so minus pi half is this point, which is equal to 3 pi half. Pi and minus pi, they both represent the same point. Pi and minus pi, because they both represent this point. Okay? Now, once you know the negative angles, here one important property of cosine is that cosine of negative theta is equal to cosine of theta. Because if you have negative theta, that means you have this triangle. So imagine this is negative theta. So cosine of negative theta, because x doesn't change, right? So some important property of cosine of negative theta is equal to cosine of theta. And you can observe that sine of negative theta is equal to minus sine of theta. Okay, so here are two important properties in terms of functions, because you can imagine cosine and sine as functions of theta. So as functions of theta, cosine and sine are even and odd, respectively. So cosine is an even function, sine is an odd function. Okay? And in terms of the function and the graph of a function, I want to show you here. So, and by the way, when I say like y equal to sine of theta or cosine of theta, theta is just a variable. You can use x as a free variable. You can use anything you want. So x, theta, t, anything you want, you can use it as a variable. It doesn't matter, okay? So here they use x as the free variable. So y equal to sine of x. You see the graph of sine and cosine here. So sine, as you see, sine is a odd function. So another super important properties of these functions is that they are both periodic. And the reason is when you have the unit circle, when you take 2 pi, you get back at the same point. If you move 2 pi at any point, if you are at any point, and if you move 2 pi, then you get back at the same spot. So that means sine and cosine are periodic with period 2 pi. So I'm writing here, that means sine of x plus 2 pi is equal to sine of x. And the same for cosine. Cosine of x plus 2 pi is equal to cosine of x. So they are periodic with, and the principal period is just 2 pi. And I also said that sine is a odd function. So that means sine of negative x is equal to negative sine of x. But cosine is even function. Cosine negative x is equal to cosine of x. That means for cosine, you have symmetry along the y-axis. And you can observe here. But for sine, you have symmetry along the origin. Okay?
Mm-hmm.
And something also from grade 11 is that you should know sine and cosine of some simple angles, like pi, pi half, and so on. And you can do this by just looking again at the unit circle. Let me go to the unit circle. Here we go. So if theta is equal to pi half, then x would be equal to what? If theta is pi half, then what is x?
0.
If theta is equal to pi half, x equal to what?
0.
Tell me.
I see. 0.
0.
Can you hear me? Oh, yeah.
Yeah. If theta is equal to pi half, x equal to 0. So that means cosine of pi half is 0. What about sine? If theta is equal to pi half, what is x? So what is y? Sorry.
Y is 1.
Y would be 1, right? So that means sine of pi half is 1. So what about pi? What is sine of pi? Tell me, Alan. what is sine of pi? If theta is equal to pi, then what is the value of y?
What's that?
If theta is equal to pi, look at this picture. So pi means this point. You
B.
come to this point, right?
Mm.
So at this point, look at the red point. So what is the y component of this point?
One.
This is theta equal to pi. What is the y component?
Y component is a
Now just look at this plane, Cartesian plane. You see?
yeah.
What is the y component of this point on the plane? Theta is equal to pi.
I don't know. One.
Y is 0.
Y is 0.
So it seems that you forgot the Cartesian plane. It's not clear that y is 0 here?
Oh yeah, it's 0.
Y is 0. It's just look at the y-axis, x-axis. What about x? What is the value of the x?
0.
X is not 0. X is -1.
Okay.
Because the radius of this circle is 1, right?
Yeah.
So the radius of this circle is 1. So the x component of this red point is -1.
Okay.
Okay. So now you tell me, Alan, how about the point 3 pi half? So 3 pi half is this point. So what is the value of y?
-1.
-1. So that means sine of this 3 pi half is equal to -1. How about cosine? So you have to know the value of x. What is the value of x here?
X 0.
X is 0. So cosine of 3 pi half is 0. Right?
Okay.
Now, how about the point? This point, maybe I just write it with another color, green color. So this green point is theta equal to 0. It's also 2 pi. Because as I said, if you move 2 pi, you get back at the same point. So what about this point? What is the x value for this point?
1.
1. What about the y value?
0.
0. So that means sine of 0, when theta is equal to 0, sine of 0 is 0, but cosine of 0, which is x, is 1. Okay? So again, I want to emphasize, you don't have to memorize these things. Although I'm going to make a table and just write these values for you, but you can just look at this unit circle. So you have to unit circle in your brain, somewhere in your brain. So always you have to imagine this unit circle. And based on this, you can get many information. Okay. So let me just make a table. And these are some important values for theta that you should know. So 0, pi half, pi, 3 pi half, 2 pi. And because this, as I said, these functions are 2 pi periodic, so it's enough to know these angles. And this is sine theta and cosine of theta. So sine of 0, as we saw, it's 0. Cosine of 0 is 1. Sine of pi half is 1. Cosine of pi half is 0. Sine of pi is again 0. Cosine of pi is minus 1. Sine of 3 pi half is minus 1. Cosine of 3 pi half is 0. And sine of 2 pi, which is the same as 0, is 0. Cosine of 2 pi is 1. And these patterns repeats again over and over. If you go like 2 pi plus pi half, 2 pi plus pi, like 3 pi, and whatever. Okay. So beside these angles, it's also good to know something extra, which are basically pi over 6, pi over 4, and pi over 3. And sine theta, cosine theta. So for sine of pi over 6, does anyone remember what is sine of pi over 6?
30 degree, I think.
Yeah, what is sine? So sine would be 1/2.
1/2. Oh, yeah.
And cosine is square root of 3 over 2.
Yeah.
So for pi over 4, sine and cosine are both equal, and they are equal to 1 over root 2.
Oh, yeah.
1 over root 2. And by the way, 1 over root 2 is equal to root 2 over 2.
Mm.
So you can either say 1 over root 2 or root 2 over 2.
Mm.
And for pi over 3, what about pi over 3? What is sine of pi over 3?
Root 3 over 2.
Root 3 over 2, and cosine is
1 or 2.
1 over 2. Okay.
Mm-hmm.
So I also want you to know this sine and cosine for these guys, like pi over 6, pi over 4, and pi over 3. So once you know this, and beside the fact that sine and cosine are 2 pi periodic, so if I come and ask you, so Lisa, what is sine of 5 pi over 6? Can you tell me?
One or two.
Negative.
5 pi over 6, because again, you look at this unit circle. 5 pi over 6 located in the second quadrant. So y is positive,
Oh, dear.
but x is negative. So sine of pi over 6 is 1 over 2.
Mm.
What about cosine?
Negative root 3 over 2.
Okay.
Mhm.
So as your homework, I want you so find sine of, so let me just make a table. It's easier. Just complete this table. So this is theta, sine theta, cosine. 3 pi over 4, 2 pi over 3, and then 2 pi over 4, 2 pi over 3, 7 pi over 6, 4 pi over 3, 5 pi over 3. Okay?
Mhm.
Just compute the sine and cosine for these angles. So it's enough to know, I mean, it's just enough to know what quadrant these angles are located at.
Mhm.
Okay, for instance, 2 pi over 3 is it's basically pi minus pi over 3. So it's in the second quadrant. But 7 pi over 6 is in the third
Third.
quadrant.
Mhm.
Yeah. Did you ask something?
No.
Okay. So yeah, so please do this. And I also want to tell you some of the properties. So you can see from this unit circle that, so some properties of sine and cosine. So you can see that sine of, for example, x plus pi is equal to minus sine of x. Well, just let me put theta because I wrote everything in terms of theta, but it doesn't matter. If I could write x. And cosine of theta plus pi is also minus cosine of theta. And we know that these are periodic. That means sine of theta plus 2 pi equal to sine of theta, and cosine of theta plus 2 pi is equal to cosine of theta. I told you that we know that sine is odd, so I'm not writing again. Sine of minus theta is minus sine theta. Cosine of minus theta is equal to cosine of theta. Cosine is even. And something else, sine of pi minus theta is equal to sine of theta. But cosine of pi minus theta is equal to minus cosine of theta. Any questions?
No.
So these are some important properties of sine and cosine, beside the fact that they are periodic. And also sine is odd, cosine is even. Okay, let me go back, look at the notes. Mhm. Okay, so because we talked about graph of these functions, so you can see these are the graph of sine and cosine. So you can use these graphs or use these two functions to build new functions by just transformation. For example, here, in this first example, instead of sine, you have minus sine of 3 times x minus something plus 1. So, and you know what this means. So you are just doing some transformation, vertical and some combinations of transformations, right?
Mm-hmm.
Or here in this example, so you have, based on sine, you build a new function which is equal to 23 plus 2 times sine of 4 pi times t minus whatever. So, for example, if you want to draw this graph, so you first draw sine of t minus 0.2. That is a horizontal shift to the right on the x-axis.
Mm-hmm.
And then when you multiply by 4 pi, sine of 4 pi times, you stretch the graph, again, horizontally. So maybe it's good. Let me see if I can show you these pictures. Just give me a second. I can draw it myself because I wanted to show you some pictures, but that's fine. So So we have sine of x, for example. So look at the graph of sine of x. So sine of x is something like this. And it goes, oh, this is the point pi, and this is the point 2 pi. Do you see my screen?
Mm-hmm. Yes.
So this is y equal to sine of x. Now, what is sine of 2x? So for sine of 2x, it would be,
horizontal compress this graph by a factor of 2, I think.
yeah. So that means, so at this point, when x equal to pi half, it must be 0. So it's something like this. This is y equal to sine of 2x. And for sine of 3x, you get exactly similarly. So it gets compressed. Right?
Mm-hmm.
Okay, so if I ask you, so if you have sine of x, the period, the principal period is 2 pi, right?
Mm.
So for f of x equal to sine of x, so the principal, when I say the principal period, that means, so first of all, sine of x plus 2 pi is equal to sine of x. And this is the smallest number. Because we also know that sine of x plus 4 pi is also equal to sine of x. But 2 pi is the smallest period. So that's why it's called the principal period. Okay. So the principal period for sine and also cosine is 2 pi. What about sine of 2x? So what is the principal period? What do you think? It's pi. Because sine of 2 times x plus pi is equal to sine of 2x plus 2 pi is equal to sine of 2x. So that means f of x plus pi is equal to f of x, right?
Mm-hmm.
So the principal period for sine of 2x is pi. It's smaller, and you can see from the picture. It oscillates faster. That means that the period is smaller. So in general, if you have f of x is equal to sine of k times x, what is the principal period? Can you guess?
2 pi over k.
2 pi over k. Let's try. Let's try f of x plus 2 pi over k is equal to what? So this is equal to sine of k times x plus 2 pi over k. So this is equal to sine of kx plus k times 2 pi over k is 2 pi, which is equal to sine of kx, which is equal to f of x. So the principal period is 2 pi over k. So for example, if you have f of x equal to sine of 6 times x, the period would be 2 pi over 6, which is equal to pi over 3. Okay?
Mm-hmm.
So, yeah, so I gave you some homework. So one of your homework was to complete this table,
Mm-hmm.
okay? Please do this. And also from the notes, I want you to do these questions. These questions from 1 to 8. Okay.
Mm-hmm.
Okay, guys. So I want to ask each of you, what do you think of today's class? Did I go too fast, or it was slow, or what do you think? Because it depends on your background. I just want to know.
I think it's a little bit slow.
It's slow. Tell me whatever you think. It's okay.
Mm-hmm.
You can say I go too fast. I want just know your opinion. What do you think? You see. Okay. Okay. How about you, Alan? Any thoughts?